for good old conservation of energy. Here are little tips and tricks to help you with these problems. First of all, energy cannot be created or destroyed, but can be converted from one form to the other. This is the first law of thermodynamics by Rudolf Clausius. And we have the equations. We're going to follow these 5 basic steps. You're going to understand the problem. What is it asking for? Be sure to use units as clues to what's given. You got to pick your equations based on the types of energy. We're going to substitute variables in the formula with the numbers in the question. We're going to solve for the missing variable using algebra. Don't forget to use paper and pencil or even a pen. You got to help. That's going to help you minimize your mistakes. Check the problem again. Make sure you've answered what the question is asking. Okay? So understanding the problem, you got to take a look at what is given and what it's asking for. In conservation of energy problems, there will be multiple forms of energy mentioned. So it's your job to identify these energies and at what point in time they're occurring. Remember, since energy can't be created or destroyed, total energy before is equal to total energy after. Now we're going to pick your equations based on the types of energy. Now, the types of energy that we look at in high school physics is pretty much just kinetic energy, gravitational potential energy, and elastic energy. So those are the main 3 that we're going to use. And I threw in a W in the after column in case we have some friction, and that's just force times distance. Frictional force times the distance. Any other work done in the process, you could attribute that to W. So W is like your miscellaneous of what you did during, before, and after. So you need to know what is happening, where it's happening, and when it's happening. What do I mean by what? Is there a spring in the problem? Is something at a certain height in the problem? Is it moving? Where is it after? Did we have a change in height? When is this thing happening? When I see some energy, did it happen before or did it happen after? These are the questions we have to ask ourselves. And that's where we pick our equations. So if it's not moving, I'm not going to put KE at that spot. If it's not at a certain height, I'm not going to put GPE. And if there's no spring involved or elastic band or anything like that, I'm not going to put PE there. All right? And if there's no friction mentioned, I'm probably not going to put W. If there's no friction or any other type of work done. So pick the equations based on the types of energy that you have in the problem, included in the before, included in the after, make them equal each other. So we're going to substitute variables in the formula with corresponding numbers in the question. So we looked at the big equation, which is basically total energy before equals total energy after. And these are the numbers that you might see. You saw this when we did the intro to energy and work. And W is equal to force times distance, whatever form that might come in. Usually they introduce that as friction times distance. If it's moving, KE is going to be 1/2 mv squared. If it's at a height, GPE is going to be equal to mgh. And elastic potential energy is going to be 1/2 kx squared. Now, even in this picture right here, I see a lady sitting on top of a cliff. I'm thinking if this turns into a physics problem, she or her tablet might fall off the cliff. And initially, all you have is mgh. And then if it wants to know the speed at the bottom of the hill, well, the only thing you're going to have at the end is KE. So what you'd end up with is mgh equals 1/2 mv squared. See? So that's just looking at the situation, knowing what's happening, when it's happening, and where it's happening. And you get to pick your equations, and then you just fill in the variables with the numbers in the question. Solve for the missing variable using algebra. Now the reason why I put this as a fourth step and a completely different step is mainly because you guys don't like to write stuff down. I say MGH equals half mv squared, and you immediately pull out your calculators and you start trying to throw numbers in the calculator. Write it down, paper and pencil. These problems are near impossible to do in your head, even if you have a calculator. So if you're solving for V, go ahead and do that algebraically on the paper, and then put it in the calculator. Or even if you use the calculator the whole time, still write it down. Makes it a ton easier. Check the problem again to make sure you have answered what the question is asking. Just to make sure. Take a look at the question again. Do I have the right units? Did I actually answer their question? Am I done? So in the example I said earlier, where you have to find velocity at the bottom of the hill. Well, if you do MGH equals half mv squared, and you just do the MGH part, and now you have the kinetic energy. Did the question ask for kinetic energy? Or did it ask for velocity or speed? Or did it ask for mass? So make sure you look back at the question to see that you are answering the actual question. All right, don't forget to ask questions. Catch y'all later.